So number one came out of the bold zone and the blue zone. We were searching there for the word magnitude. Two sadly did not come out of the blue zone, and it was the magnitude was bolded, and then it explained to you what a magnitude was. A magnitude has two parts to it. Anybody think you picked up on what the magnitude, either of the parts of the magnitude are?
Number and a unit.
There is a number and there is a unit, like 50 meters. That entire thing makes up a magnitude. There's a number and there's a unit. Four, we're back to like the bold blue zone, as well as conversations we've had other times. Hello? Oh, I was so hoping you were going to be a real person. Oh, it's just a recording. Now you'll never know what I was going to do to that person on the phone. Someday, if another person calls, if it's a person, we'll have some fun. Okay, so four is a conversation we've had other times. Examples of scalars could be distance or speed, or the two that you've historically used in other chapters and other conversations that we've had. Five for vectors. Vectors also have a magnitude. That would be worth half a point because there's two blanks here. And then what makes a vector be a vector? Direction. So we have magnitudes and we have directions. Example of vectors. Historically, you've more often used displacement, which is similar but different to distance. You've used velocity, which is similar but different than speed. They also let you use, I think they mentioned force in this reading, they mentioned maybe momentum in this reading. Acceleration is also in that club. 7, scalars are added algebraically, and I'll illustrate that to you in a moment. Vectors are added graphically on 8. 9, you could either do it with words or pictures. It all involves arrows. If you have arrows involved in any way, by either drawing an arrow or by having some like symbols like this with them, that's a traditional variable. That is a vector variable. Or if you prefer, some people in some books will do little half arrows. That's also acceptable. If you just drew me an arrow, I'm good with that. Pretty much anything with an arrow in it is a winner on 9. 10 is that you position them head to tail. Or if you want a longer sentence, you put the head of one on the tail of the other one. What do you suppose this is? Head or tail? That's the tail. That's the head. It's like an arrow head, right? Like that's a word from the English language. So that's the head, that's the tail. 11, the word we're looking for is resultant. 12 and 13, same answer twice. The first word's a scalar, the second word's a vector. Or if you prefer an alternate explanation, the first word does not have a direction involved, and the second word does have a direction involved. Something along those lines. 14 is independently. And I'll come back and explain these terms once the own paper is back to the owner. So we might as well pause that for a moment. Okay, so for next time, good news on the reading. There is one new point.
Yes.
Total of 15. Most of this being a repeat, so we'll repeat what the repeats are and try to explain a little bit what's going on. More good news, there is no mathy homework yet, which astounded me. They've saved the mathy homework for some reason until after 5-6, but I've got a big board full of mathy because I might as well just do it because we have time today. So I'm going to get some math done out front to explain to you a little bit what's going on in this chapter. But this won't affect your homework life tonight. Tonight you just need to read 5-6 and come up with one new fill-in-the-blank point, and that's it. Let's see. Some of these questions will go differently than they went today in structure. So after number 1, you'll have yourself an 8-point question that kind of like groups these things into 2 main categories. So two main categories of things you read about is who versus who. Scalars versus vectors. So I'll ask you to do a name, to do a definition, to do an example, and tell us how we add them. So on the name category, we have scalars versus vectors. On the definition category, scalars have only a magnitude. Vectors have both a magnitude and direction. For an example, you have no shortage of choices. In the scalar world, you could pick distance or speed, and there's others. On the vector side of town, displacement, velocity, others, force, momentum, acceleration, whatever you like. On the adding method, in the scalar world, it's algebraically. In the vector world, it's graphically. So here's an explanation I said was coming on that. If we go in scalar world, 3 meters plus 4 meters makes 7 meters. That's what you're used to doing. They're just basically combining like terms, right? Like meters and meters make meters, you just add stuff up. It's algebraically, because you're adding it with your algebra, combine like term skills. In vector world, it is possible that 3 meters plus 4 meters might make 7 meters, but it's highly unlikely. If I walk 3 meters, the only way that I could add on 4 meters and get 7 meters is if I would do what? Keep on going in the exact same straight line in the exact direction. And in that case, even in vector world like this, 3 plus 4 still makes 7. But it's highly likely that after you've taken a walk in one direction, you're probably going to walk some other direction. If you walked straight back, 3 meters plus 3 meters this way plus 4 meters that way would actually make 1 meter that way. Because you like wasted your 3 meters and went like an extra meter. Anybody with geometry wisdom, how could 3 meters plus 4 meters make 5 meters? Pythagorean theorem kind of thing, draw ourselves a right triangle. If I went this way 4 meters, 3 meters plus 4 meters just made 5 meters. I could make any number anywhere actually between 1 and 7 if I just went at different directions. If I had 3 meters and then I opened this up a little bit wider, would this be more or less than the 5? That's more. If I opened it all the way, what was the highest we said we could go? 7. The lowest we could go is by backtracking, that was 1. And by doing some angle in between, you could actually get any number from 1 to 7. Fractions, decimals, partials, whatever. It's like, you don't know. Vectors are added graphically, meaning you're going to have to draw a picture. Okay? There's not going to be a way to figure out what's going on with vector adding unless you draw yourself a picture of where the two things are going. Question about that concept. Okay, back to quiz world then. I'll ask. 9 is going to stay the same. Just anything about an arrow, or draw an arrow, or draw one of these things. That's all good. Number 10 stays the same. Or tomorrow it'll be 10, stays the same. Today's 10 becomes tomorrow's 11. It just stays the same, head to tail. These are drawings of vectors head to tail. I drew my first vector, I drew a tail, I came to a stop at the head, and then at the head I made a new tail and like set a new vector going somewhere. That's how we're going to add those graphically, is by getting them positioned head to tail. 11 stays the same. When I drew this dotted thing right here, that's called the resultant. So I had a vector, I added on another vector. This dotted third answer thing we had to figure out, that's called a resultant. 12, 13 stay the same. 14 also stays the same. Explanation of vectors acting independently. A location on Earth you might find 2 vectors would be a person who decides to swim across a river. Okay, so if this room is a flowing river and I tried to swim straight at Cassius, all my effort is directed swimming exactly at Cassius. Why would I not end up right at Cassius? What's that? There's a current that's going to push me downstream, and I'm trying to swim to Cassius, but I'm going to end up like down by Josh or Zach or something somewhere. The river's going to send me downstream. My velocity is a vector. The river's velocity is a vector. And what happens when they work together, I end up going diagonally. However, whether I do or don't swim across the river, does that change the river's speed? No. Whether I'm swimming in a river or a public stationary swimming pool, does it change my swimming ability?
Yes.
Not really. My ability to swim in a river is the exact same as my ability to swim in a pool. If I can swim 5 meters per second in a pool, I can swim 5 meters per second in a river. The only difference is the river's going to send me somewhere other than straight, but my swimming ability is unimpeded. Like, if I'm driving on the turnpike and there's a 50-mile-an-hour crosswind, does my car still drive 60? Yeah. But the wind is trying to push me to go somewhere else. But the wind doesn't affect my car. Does my car slow down or speed up the wind? No. The vectors are independent. I, as a swimmer, can't change the river. The river, as a thing, can't change my ability to swim. They're independent. However, they can sort of work together and send things in a diagonal direction. But independently means the one thing really doesn't affect the other. They kind of like cooperate, if you want to put it that way, I guess. But that question will stay the same. Some other things just to be aware of. If you've already been, well, if you are in trig right now, when things start to go in diagonal directions, the only way you've learned how to describe diagonal directions was a thing called angles in standard position. That has nothing to do with this class. Okay. But we did a bunch of things in chapter 1 where we had, like, drew ourselves a coordinate system. 0 was this way, 90 was up, you know, from 0 to 360. That's how we did directions in chapter 1 together. If you're in calculus now, you've completed trig. Sometime later in trig, we had another direction measuring system. Anybody remember what that was called? Started with a B.
Beta.
It was, the letter beta was involved. There's a thing called bearing. Okay? For bearing, 0 was up instead, and then it rotated like the other way. That has nothing to do with this class. What this does is a whole different system of measurement, so we need to practice that for a minute just to be able to do this. And again, there's no math tonight, but here comes a necessary skill for your life. If I want to send you in a direction, the way the physics book is going to do this is like map style, where this is north, south, east, west. If I send you 60 degrees north of east, is that heading you up left, up right, down left, or down right? Where is that heading on?
Right.
Can you wait a little bit? Because you're going to need to know how to do this.
Upright.
Upright. But it matters where we stick the 60. It would be debatable whether this is 60 or this is 60. Does anybody have a thought on whether angle number 1 or angle number 2 is going to be the 60?
2.
It is number 2. 50-50 guess, or did you have a reason? Whoever
It's
said that.
with east, like it connects to east.
Yeah, the
That makes sense.
second direction is the more important of the two. If we're moving to the north of east, it means sort of like our intention was to go east, but we didn't end up going east. We ended up getting forced a little bit to the north of east. Okay, so if we are north of east, the 60 degrees would touch the east. However, sometimes you do an answer in your homework, and there's another choice for that description that is just as good. Using geometry, if this is a 60, this is a 30, because these two have to make 90 to fill that quadrant. Someone else's paper might say 30 degrees, and their answer be just as good as yours. But where are they in the northeast world? They are east of north. because the 30 is touching the north line, the line you're touching goes second. So if you're doing homework comparisons with a friend or a book or the blue or whatever, and one of you has 30 and one of you has 60, you might both be right if your directions are like inverted. Let's try again. If we go west of south, let's head to an area first. Where are we if we're west of south?
Down left.
Down left. That is west of south. Should the 70 be angle 1 or angle 2? Angle 2. Because the south is mentioned second, so the angle should touch the south. If your friend has a different answer, they might be right. Who is 70's neighboring friend? 20. But not west of south, south of west. Because the 20 is touching the west line. You shouldn't have to do a picture every time to do that comparison. How do the numbers compare to each other? Add up to 90, and what did the directions do? They just swap. So if somebody has 6, someone else could have 84, but they'd have to say south of east. So there's like dual direction possibles. Question on that concept? Here's some algebraic adds. 50 meter east and 30 meter east together.
80 meters east.
80 meters east. Yeah. Here's another easier one.
50 meters south.
50 meters south. Slightly more difficult one.
30 meters west.
Agree. Because when you have all opposing directions, we're gonna subtract them. And the winner is, how do you know who the winner is? Bigger number. So here's another somewhat easier one.
30 meters south.
30 meters south. That's still vector adding because they had direction, but you don't always have to do a picture. If it's just simple, same directions or opposites, you can just add subtract. This one, you're going to have to do a picture. So here's my suggestions on vector drawing pictures. Always make a starting point for vector 1. How can I draw you 50 meters west? Go left. At the head, I'm going to now need to continue and do the 20 meters north. Where's that going to go? Up. So 50, 20. This is my answer. What was the official physics quiz name of the answer? It is the resultant. I have another fact involved in this. It is a 90-degree angle. What I'm always going to want to know is how long is this, and also what is the angle at the starting point. And we have a myriad of ways that we could do this math. What is a way we could do this? Square add root would work for this. That'd be fine. What's the other ways we could do that? Law of cosines. Potentially also we could use law of sines. Potentially also your favoriteest thing for people presently in Traeger Calc. Run your programs. We're going to turn the programs back on. People that are not in Traeger Calc, if you want to have a program, I would highly recommend you get a program in your calculator. This would be called an SAS triangle because there's a side, there's an angle, and then there's a side, like as a little collection of things in a row. On the YouTube channel, there is a video titled Trig Video SAS Program on the YouTube channel. We're in Trig class, we went through this whole thing and we wrote the program together, by we meaning mostly me. Okay? But it's just a matter of go on the video and see what all the commands and stuff are to be able to type that into your calculator. SAS, go ahead and grab that, watch the video and like program that in there. If you do that, life becomes as simple as what I'm about to do. Where I'm going to go program SAS and I hit enter and my calculator says enter two sides and I say 20, I say 50. My program asks me enter my angle and that number is a 90. I hit enter again and it tells me my side is 53.1. And then it gives me two angles. How do I know which angle I want?
The smaller one.
The smaller one, because it's across from the 20. So if I grab the smaller angle, that's 21.8 degrees. And then where am I? Like we were over there, like south of Wests and all that stuff?
You are.
North and west?
Agree. Because my first move I made was
West.
west. So I am west of something or something of west?
Something of west.
Something of west. And then the direction I drifted was north. Something about that? That was not bad. If you didn't have a program, you wouldn't be that bad off for that one, because we could have done a square head route, you could have done like some Oscar had a heap of apples to get the angles. It wouldn't have been a huge deal to us. This one will be a better deal. If I send myself 50 meters south, I'm always going to make a starting point, and I'm going straight on down. At the tip, I need to imagine, and it's hard to imagine, so I might be better off to draw myself a little map system. I'm headed 26 north of east. Where's northeast world? Top right. Is this the 26, or is that the 26? 1 or 2? 1. So here's my 26. This is a 50. This is a 30. That's what I'm after. I have a little bit of a geometry thing I'm going to have to do. To run a program, I'm going to need to have 3 facts in a triangle. I presently have 2.
90 minus 26.
90 minus 26, this is going to be a 64. At which point, we're always after how long is the dotted thing, called the resultant. And then which angle am I always after? The starting point. That's why I always start off by drawing myself a big thing like this to highlight for me later, this is where I want to look to get the angle. You could use all kind of laws of sines and cosines on this if you want to. But I think it's going to be much simpler to just get these programs in here for everybody. And this is, again, what kind of a triangle? It's another SAS. 98% of our triangles are going to be SAS triangles. So if you have a working SAS program, that is going to be your play. So I punch this in, enter 2 sides, 50, enter the other side, 30, enter my angle, 64. The side comes back 45.7. And then how do I know on this one which angle I want? The smaller one. Is it always going to be a smaller one? No, that's just luck. 30 was the smaller side, so I want the smaller angle my program says, which is 36.2 degrees. Which way did I just head first in my drawing? South. So I'm south or I'm south? Of south. Which direction was I set?
East.
I'm this way of it, so that's east of south. Somebody once asked me, is there such a thing as south of south? And I laughed and laughed. South of south would be south. There's no south of south. That's not a thing. One of the words needs to be either east or west of north or south. There's going to be one from each axis, basically. Again, there is no homework off of this, but these skills become necessary to do the homework tomorrow. After you read 5-6, they spring homework on you. In the meantime, you might want to take a day, make sure if you are in trig that your SAS actually works. Make sure you have your calculator license. If you're not in trig yet, check the YouTube video out. And if you need help finding the commands and stuff, your biggest issue watching the video might be later figuring out which buttons to push to get the thing typed in. If you need help with that, I can help if you visit me, but SAS is out there in the YouTube world.